Hello and welcome to Math Series TV. Today being the day 14 of our 60-day geometry prep, we are going to do right angle triangles. But before that, if you've not subscribed, kindly subscribe and let's get started. Now, what is a right angle triangle? It is a triangle with a right angle. Okay, so when we have this triangle, we have one right angle here. Say this is the angle called theta. Okay, let's say this is our angle. The opposite is the angle that faces the angle. Okay, the side that is facing the angle we are talking about is the opposite. So you see this one is facing this angle, so here is opposite. The side that faces the right angle, which is the longest side, is called the hypotenuse. Okay, so this side is facing the right angle, so it is called the hypotenuse. Okay, then we have the adjacent, which is the side next to the angle. So if this is opposite and this is hypotenuse, we all realize that this one will be the adjacent. Okay, now what does Pythagoras theory state? It's a nice man who was called Pythagoras. He developed this theory, and he said for any right angle triangle, the square of the hypotenuse is equal to the sum of the square of the two sides. So if this is my triangle, if I square this one, so BC, this angle, this line squared is equal to BE, this line squared, plus AC, that is this line squared. So this is what we call the Pythagoras theory. Okay, so let's see some ways we can use this theory to solve certain questions. We have a question like find PQ in the figure below. Where is PQ? Line PQ. Okay, line PQ. And we can realize that this one is which side? The hypotenuse, exactly, because it is facing the right angle. I hope you are getting. So line PQ squared, as in Pythagoras theorem, equal to line PR squared plus line RQ squared. So PQ squared equals PR. What's the length? 12 squared. So 12 centimeters squared plus RQ. What's the length? 5 centimeters squared. Okay, so PQ squared is going to give me 12 squared is 144 plus 5 squared is 25. So PQ squared equals 144 plus 25. Now I get 169. So if I want to find PQ, what I'll do is that I'll square root this side and square root this side. So I root this and this again, and I square root this part and square root this part, so that square root to cancel square. Now line PQ equal to square root of 69, and the square root of 69 is 13. So line PQ is 13 centimeters. Okay, let's look at another question. Find the length of AC in the figure below. Now for this one, we are finding this side. If this is our angle, if this was to be our angle, it means that here is the opposite. Okay, and here is the hypotenuse, here is the adjacent. So in Pythagoras theorem, the hypotenuse square, so CB square, this is the hypotenuse, is equal to this side, the squared, CA squared plus AB squared. Now what is CB squared? Is 5, right? So 5 squared is equal to CA. You don't know, so you can make okay, CA square, let's write this like that, plus AB. What is AB? It's 3, so 3 squared. Now how do I make CA stand alone? I have to bring this one to this side. Okay, so I have 5 squared. When 3 squared becomes minus 3 squared is equal to CA squared at the right side. Okay, now let me bring this here and bring this here. It's the same thing. So CA squared equal to 5 squared minus 3 squared. So now CA squared equal to 5 squared is what? 25 minus 3 squared is what? 9. So CA squared is going to give me 25 minus 9, and that's 16. How do I find only CA? I have to square with this side and square with this side so that the square will cancel the square root. Now CA is going to give me the square root of 16. And how is the square root of 16? 4. So 4 centimeters. That will be my CA. Okay, let's talk about the last thing. Now we have something we call Pythagorean triples. It is a set of 3 integers which obey the Pythagoras theorem. Okay, so like in this one, 3, 5, and the last I read this part, the one we found is what? 4. So 3, 4, and 5 are Pythagoras triples. So what are some of the Pythagoras triples, or the integers, 3 integers which obey Pythagoras theorem? Okay, so one of them is 3, 4, 5, as we saw. 5, 12, 13. We have 6, 8, 10. We have 9, 12, 15. We have 12, 16, 20. We have 15, 20, 25. We have 7, 24, 25. We have 8, 15, 17. We have 15, 36, 39. And we have 9, 40, 41. So it should be, some of them should be in your head, okay? Alright, so like when we were solving the first question or the previous question we were solving, as you should have in your head that the answer is 4, okay? Because 3, 4, and 5 are Pythagorean triples. Please, I hope you are getting me. Yes, thank you very much for your time and attention and everything. I will see you in the next day. Do all to subscribe and stay blessed. Bye bye.